So now that we know alternate dark and bright fringes are formed in Young's double slit pattern, now we'll find the fringe width. Okay, that is the width of a dark fringe or a bright fringe. Okay, so here see this is a schematic diagram for that Young's double slit experiment. So here we have these two coherent sources S1 and S2, and the slit separation is D. Okay. And S1 and S2 are very close to each other. So D is a very small length. Now compared to D, the screen XY is placed parallel to the slits and D is much more greater than small d. Capital D is the distance between the slit and the screen, and this capital D is much more greater than the slit separation small d. So here you see, so we have these two waves, one wave traveling along S1P, another wave traveling along S2P. Okay, so you see, so the C, this is the C is the central point of the on this screen. Okay, so the point P where we had earlier find the intersection, it is at a distance x from the center of the C. So we can write that at first write S1, S2 is small d, okay, and separation between the, so separation between slit and the screen is equal to, suppose it is equal to, so this point is O, that is this midpoint between the two slits, and C. So if we join OC, it will give us the distance between the screen, and the slit. So we can write OC equals to capital D. Okay, and point P is at a distance x from the center of the screen C. Okay, so now if we join, if we draw a line parallel to this line OC, okay, so this line will reach a point A on the screen. Okay, and if we join a similar line parallel to OC from S2, then this line will reach a point B on the screen. Okay, so both S1A and S2B equal to D. Okay, so both S1A equals to S2B is equal to D. Okay, and you see, so C is the midpoint of A and B. C is the midpoint between A and B. Okay, so like O is the midpoint between S1 and S2, and S1 S2 is equal to D, then OS1 is half of D, which is D by 2, and OS2 is half of D, which is again D by 2. So similarly AC is equal to D by 2 and CB is also equal to D by 2. Okay, so we can write S1 is 2 equal to AB. Okay, and AC equal to BC is equal to half of AB, which is half of S1 S2, and we know S1 S2 is D, so it is equal to D by 2. Okay, so now we'll find the fringe width. Okay, so for that, at first let us look at this right angle triangle over here, which is S1AP. Okay, this right angle triangle over here, S1AP. So we can write in a right angle triangle, the right angled triangle which is S1AP. S1P is the hypotenuse, So hypotenuse square is equal to base square, which is S1A whole square, plus the perpendicular square, which is PA square. Okay. Or, so S1A, if you look at the S1A, what is S1A? S1A is equal to D. And PA, so what is the value of PA? You see, PA is PC minus AC. So it is X minus D by 2. Okay. So S1A is D square plus PA is equal to PC minus AC. So PC is X and AC is D by 2. Okay. So PA is X minus D by 2 whole square. So S1P square is D square plus X minus D by 2 whole square. This is equal to, this is equation 1. Now if we look at this triangle, another triangle S2BP, then in this right angle triangle you see S2 is the hypotenuse, S1B is the base and BP is the normal. So we can write that S2P square is equal to S2B square plus BP square. So we can write in the right angle triangle S2BP in the right angle triangle S2BP, the hypotenuse square S2P square is equal to the base square, which is S2B whole square plus normal square perpendicular square, which is BP square, equal to, now S2B is equal to separation between the slit and the screen, which is D square. Now what is BP? So if we look at this BP, you see it is equals to PC plus CB. Now PC is equal to X and CB is equal to D by 2. So it will be X plus D by 2 whole square. So we can write, now BP is equal to, if we write in this way, BC plus CP, BC plus CP. So when BC is D by 2 and CP is X. Okay. So BP square is X plus D by 2 whole square. So S2P square is D square plus X plus D by 2 whole square. So suppose this is equation 2. So now if we do equation 2 minus equation 1, what we'll get? So we'll have S2P square minus S1P whole square equal to D square plus X plus D by 2 whole square minus, we have D square plus X minus D by 2 whole square. So it will be, see it is like S square minus B square. So we can write it as S2P minus S1P into S2P plus S1P. Okay. And here you see this D square and minus D square will be cancelled and we will have X plus D by 2 whole square minus X minus D by 2 whole square. Okay. Now let us keep S2P minus S1P as it is. Okay. Now you see this, as this slit separation is very small. Okay. So this is D is a very small distance. Okay. So you see this S1P and S2P are almost equal to separation of this slit. So we can imagine if this distance shrinks, okay, come very close to each other, then this S1P and S2P, this angle will decrease. They will become nearly 0 degree. That is, this S1P and S2P will almost be equal to separation between the slit and the screen. That is, their length will be almost equal to capital D. Okay. So we can write, since S1 and S2, S1 S2 is very small Okay, the separation between the slits is very small. We can write S to P is almost equal to S1P, which is again equal to capital D. Okay, so we can write that this S2P and S1P will be equal to D plus D. Okay, and here it is like the form we can apply the formula for A plus B whole square minus A minus B whole square, which is equal to 4AB. So it will be 4 into X into D by 2. Okay, so here we have S2P minus S1P into 2D equal to 2x small d, or S2P minus S1P equals to xd by d. Okay, now you see S2P minus S1P is the path difference between the waves coming from S1 and S2 and reaching point P. Okay, so now depending on the path difference, if there is a constructive interference at point P, then the path difference will have certain value, and if there is destructive interference at point P, then again it will have a different value. Okay, so now we will apply the condition for destructive interference and constructive interference. So we can write, as this is the path difference, so we can write delta is xd by d. So we can write, therefore path difference between two interfering waves at a distance x from the center of the screen is delta equals to xd by d. Okay, so if you know the distance of any point from the center of the screen, see here P is at a distance x from the center of the screen D, then you can find, and you also know the slit separation D and this the separation between slit and the screen capital D, then you can easily find the what will be the path difference at that point on the screen.